Hey guys, if you missed my face from last week since we didn't have a video, here it is. Again, I know I say this every time, but I definitely miss your guys' faces. This whole thing is just crazy and it really does take the fun out of teaching. So I'm really excited for next year when I will hopefully get to see your faces. So please, Lord, let this corona thing end. But one thing from this, and I really hope that you feel this way about yourself, is how proud you should be of the students you guys have become through all of this. I was talking with my roommate a few days ago about how hard this has to be for you guys. I can't imagine learning online when I was in high school. I don't know if I would have had the tenacity and the resilience that you guys have had. And so I just want you guys to know how proud I am of you, because this has not only been a very challenging thing just with technology, but also for some of you to really come out of your shell and be realistic with yourself about when you need help and asking for it. So I really think this has been a very wild ride, but I think it's also making us stronger teachers and stronger students, because we now have to think outside of the box. When being in a school building, we may not have had this kind of opportunity to do so. So I really hope that you guys are proud of yourself for what you've accomplished so far, and I hope that you continue to find the motivation to keep working. I know that for me especially, I just kind of want to lay on the couch some days, and I have to force myself to do the things that I need to do. So if you find yourself in that mood of like, God, I just don't want to get out of bed, understand that it's completely normal, but also do something that you enjoy. Even though my dog hates it, going on another walk with my dog just kind of brightens my day. Now that the weather is nice, it's a whole lot easier. Maybe it's just going out and shooting a basketball, or even just playing catch with yourself with a baseball or softball. Video games on lines with your friend, like just something that you enjoy, because this is such a hard time to just be completely separate from everything that we're used to and everyone that we're used to. So I hope that you are finding that motivation and you are continuing to work, but you're also finding time to enjoy the little things that we kind of take for granted at times. So we are getting close to being done. We just have a few weeks left. So we got this week and next week is kind of a review for seniors if you're a senior. But for the rest of you, we're going to be doing regular stuff this week and next week, and then that third week is going to be final review. And then that last 3 days, the 18th, 19th, and 20th, will be your final. So one of those days, whenever you get a chance, you'll take that final. So again, hope that you're doing awesome, and good luck this week. This week we are starting the dreaded exponential word problems. I promise you they sound a lot harder than they are. So we're going to go back to this exponential function that you guys have seen over and over and over and over. So let's talk about what each part actually means. So A, when we're talking in word problems, A is normally the beginning amount. Okay, so we'll do examples, but if we're talking about one of your examples is a club having so many members, the number of members it started out with would be the beginning amount. B, and usually we see B or we see R, but that is the rate. So if it goes up 20%, So sometimes rates are given in percents. Sometimes they could say that our rate is doubled. So it could just be 2. But usually that's the 2 ways it's given to you, either a percent or it'll have that keyword that will tell you what goes in place for B. And then X is generally, I'm just going to do it in red again, the time. It doesn't always have to be time, but that's just your exponent. Normally with these type of problems, your exponent is time. And then we have this graph of an exponential function. So there's, breaking off of that, I guess I should say, there is exponential growth and exponential decay. So exponential growth typically looks like this. So it starts out very low, and the x values, as you can see, will get higher and higher and higher. Now, another version of this graph is like this. Even though it's on the bottom, it's still considered growth because it starts very close to this axis and moves away from it. So that's the way you can tell between growth and decay. Because it starts close to the axis and then the end of it is away from it. So this is the typical equation for growth. So A is still going to be that beginning amount. Okay. R is still going to be that rate. And then T is still, obviously, time. Now, the one important thing, and I'm going to write it here just so you see it and you hear it, the rate needs to be in numerical form, not a percent. So that means that you have to change percents to decimals, and we'll talk about that once we do an example. So again, very important, R needs to be either a decimal or a number. So if it's 2%, you're not going to write 2%. You know what? I'll just even write that. 2%, that's not okay. Don't do that. We want it to be 0.02. Basically, you move the decimal place or the percent sign 2 spots over. Or divide it by 100, whichever is easier for you to think about. So that's exponential growth. So if you look here, exponential decay is kind of the opposite. It starts away from the axis and moves closer to it. So it's the complete opposite. And I'll do the other one below. So we start away from the axis and move closer. So both of these lines are decay. One is just negative y values. The other one is just positive y values. But both of these graphs are decay, just like both of these were growth. And then your A is still the beginning amount. R is still the rate. T is still the time. The only difference, honestly, between these two equations, growth has a plus, decay has a minus. So that is the growth and decay equations. So let's go ahead and do an example from day 1. So I wrote it out just like it looks on your paper. So it says annual sales for a clothing store are $270,000 and are increasing at a rate of 7% per year for 3 years. So it first asks you to write the equation, and hopefully you're thinking, is this growth or decay? Well, when you see the word increasing, hopefully you're thinking growth. So we know that it's going to have our starting amount 1 plus our rate, and then our time. So our starting amount was this right here. The $270,000. That is our starting amount. Okay? There's always going to be 1 plus, just like up here. There's always ones in these equations. So it's always going to be 1 plus our rate. And our rate, I'm going to do it in blue here. This is R. But we want R to be numerical. So 7% is the same as 0.07. So in here, I'm going to put 0.07. And then I'm just going to put T for our time. So there's the equation. There's our first answer. Now, the second part of this has us plug in for the time. So we want to put 3 in for T. So the second part of this comes from plugging it in. I don't know why I put that extra 0, but it's fine. Same thing. So I'm actually going to show you how to do this on our Desmos because that's what it seems like most of you guys are using. So here is my standard Desmos. So I'm going to put in that 200, I don't know where I'm getting the 27, but 270,000 and then parenthesis 1 plus 0.07 parenthesis, and then this a to the b should raise it to an exponent, and that's where I want to type in 3. So this right here is my answer. So again, this little a with the b, that is how I get an exponent. So going back to my paper, my answer is 3,000,307,61.61. I don't know why I put that parenthesis there. We're gonna pretend that wasn't there. There we go. It was never there. All right, so there is our answer for number 1. Sorry, the camera wasn't really on it. But again, that's exactly what our calculator in the Desmos gave us. So that is using the growth. So now let's look at a decay. So number 4 is an example of decay. And it says the population of a school is 800 and is decreasing at a rate of 2% per year for 4 years. So it wants you to write the function. And I know that I need to start with my beginning amount. So this right here is my beginning amount. So that goes first. Now, because I know that it is decreasing, that means it's 1 minus because it's decay. And then I have my R right here, which I don't want as a percent, I want it as a decimal. So I'm going to move the percent sign over to the left 2 spots, which makes it 0.02. And then to the T power, which again, this tells me what I'm plugging in for T. So now I do that. So for most of these, you should have 2 answers. Again, I don't know why I'm doing this extra 0. I apologize. I guess it's just habit. So you should have one that's just writing the equation, and then the second one where you're plugging in the actual number. So again, I go over here to our Desmos and I type in our 800 because that was our starting amount. And then parenthesis, but it's 1 minus this time because it's decay, and then 0.02 for that 2%. Close my parentheses, and then this A, B, the little b up at the top makes it an exponent, and I want it to the 4th power. So in 4 years, instead of having 800 people, we now have 737.89. Since we're dealing with people, I'm just going to go ahead and round that. We can't have 0.8 of a person. So I'm going to just round this to the nearest whole number because it's a person. It's not a dollar amount. So just kind of use your judgment there. So I'm going to round this to 738. So I'm going to go back to my paper real quick. And I'm going to say this is about, that's what this means, 738 people, I guess. Since it's not a dollar amount, it was a population. So just make sure you're paying attention to what the question is talking about. Obviously, with dollar amount, you can have a decimal, but you can't have 0.8 of a person. So that's why we rounded to 738. So that is decay. So now let's do an example of one that doesn't give you a rate as a percent, which is like number 7. So I wrote it all out. So number 7 says, starting with 25 members, a club doubled its membership every year. Write the function that expresses the number of members in the club after n years. Then find the number of members after 6 years. So there's our function. Okay, so I guess I should be using n like they are, but it's okay. That part doesn't really matter. So this one is an example of the first type of equation that I gave you. So more like this. Now, I know that it is growth and decay, but this one is giving me a rate that is doubling. It's not giving me a percent. So if it doesn't give you a percent, we just want to write it, again, still with the original members, so that's A, so 25. But instead of writing 1 plus, we're not given a percent. It just tells us that the club doubled. So we don't want 1 plus whatever doubling means. We just want to show that it is doubling. So this is our R still, but again, it's not a percent. It's just a number. What number represents doubling? 2, right? 2 is doubling. If I said tripling, what would that be? 3, right? So 2 is the only thing that goes in there. There's no 1 plus or 1 minus. So if you're not given a percent, you should just have a number in here. And then we want x power or t power, whatever your exponent is that you want to use. So there is our equation. Now we're ready for the 6 years. So I'll write this in blue. 25 times 2 to the 6th power. So this one should be pretty basic in the Desmos calculator. So 25 parenthesis 2 parenthesis, and then make that exponent 6. There is our answer. So our club increased to 1,600 members. So going back here, 1,600. So again, you only don't use the 1 plus or 1 minus when your R is not a percent. And that is exponential growth and decay. So it should be pretty straightforward on your worksheet, whether it's growth or decay, because it will say increasing or decreasing, or it will say like went up, went down, that kind of thing. But if you have further questions, please feel free to reach out. I am here to help you. So you got day 1 and day 2, and you have 3 problems done from day 1. So these are from day 1. So good luck.